Hi, folks. So, from the first week of our class this year, we've really talked about how math can be a way to tell a story. Now, we want it to be clear, but sometimes we want to quickly get to the point and solve a problem. So, that's where equations come in. And that's our big idea for this week. Today's story that I want to tell is about a race. So, Eli and George are racing. Mr. Morin has kept stats on both the boys running. I'm hoping to retire on their NFL salaries. Here's what Coach Morin knows. Eli has done the race, the 200-meter race, in about 45 seconds. I timed him. Georgie has done the race the 200-meter race in about 60 seconds. That's respectable. He's probably going to be a lineman. He's a big guy. Let's break down what the story of this race will look like using some of the things that we already know about trying to break down these kinds of situations. Okay? In order to build an equation here, I want to start to think about, well, first of all, how is the story starting and how is the story changing? It's a common theme that we've been talking about through all of the first couple of weeks. So we know, well, if the race is just starting, we haven't gone anywhere. So 0 meters, and that would be for both of the boys. We do know, and I'm just sort of thinking about the candle lesson that we did. If we knew how far it went down and then how long that total was, we could find out how much that candle was burning per second. We're going to do the same thing with Eli's race stats. So we know it's 200 meters for 45 seconds. And we could even look in our table and start to say, well, okay, well, so we know when he's going to finish, right? 200 meters. We expect that he's probably going to finish that 200 meters here in 45 seconds. But if we want to know these times in between, we're going to really want to know that rate in a way that's a little bit more usable. And so we're thinking maybe meters per second. So 200 meters in 45 seconds, if I divide that, what I get is about 4.44 meters per second. So we're going to sort of build our story. And I'm really thinking about the experience that we've had over the last couple of weeks, right? We started at the beginning of a story, then we thought about how it changed, then we go to the next point in the story, and we think about from the story from the beginning, the middle, and the end. So we're going to sort of build equations by thinking through the process in the same sort of way. So every time my clock stops after, if I were to freeze the playback, the video playback of his race, each second, Eli travels 4.44 meters further. Now, we can just extend this process. We can just go ahead and say, okay, well, that's going to happen every single time that we go 1 second. So you can see that what we've done here is we've kind of zoomed in on 1 second at a time. We're thinking about meters per second. It's 4.44 meters per second. So we're going to break down that first 10 seconds as a way to sort of extend this using a pattern. So here what I've got is each time I travel from that 0 meter start, I'm going to add 4.44 one more time. So here's what this looks like as we sort of extend that. Okay? So each time I add 4.44. So first second, now it's at 4.44 meters, then it's at 8.88, then it's at 13.32. And so we could do this process and sort of just keep counting by 4.44 until we got to 200 meters, then we'd know the end of his race. But as I said, math is about telling a story, and we certainly want it to be clear. But sometimes we want to get to the finish. We want to get to the point of the story because that's what we're interested in. That's the problem that we're trying to solve. So what I want to notice here is that I'm really purposefully using this language. So I started at 0. I added 4.44 one time. That gets me to 1 second. If I wanted to go right to 2 seconds, Well, I would start at that 0 meters. I would add that 4.44 two times. So I just sort of laid out the beginnings of an equation here. I'm starting all the time at the 0 meters, and then I'm adding 4.44 the number of times that matches our seconds. So for example, we could let's just do one more together here. If I wanted to know for the third second right here, 13.32. Well, that would be 4.44 that we added 3 times. So if I add 4.44, add 4.44, add 4.44, what we're really adding is 4.44 times 3. We're adding 13.32 seconds to our starting distance, which is 0. And so we can see that the beginnings of our calculations here are going to give us what we expect by just doing that repeated addition. Okay, so for 3 seconds. We could go down now and use that same pattern. And we don't have to go 1 second at a time now. We can say, oh, well, for the ninth second, well, that would be, I would start at the beginning of my story at 0, and then I'd be adding 4.44 9 times plus my 0 that I started with. And so that would calculate out to 39.96 meters after 9 seconds. So what we can notice here is that we can actually use this to write an equation. All of these calculations all sort of have that same pattern. And so we can turn this into a formula. Now, I want to mention here that I've used this raised dot to represent multiplication, and I'm going to be consistent about that throughout our class. I don't like the x to use multiplication because we're going to be using x as a variable in our algebra class. So the basic pattern here that we can see is that if we want to write an equation for a linear pattern, what we have is our rate of change times how many steps we took. So this was our 4.44 meters per second. And then this x is representing our time in our story problem. But then we also had to add in whatever we started with. And then in our case, we were starting at 0. So this is plus 0. So we can see the equation for Eli's race would then be y equals 4.44 x, or times x if you want, plus our 0 starting point. Now, what's cool about this is now what we've got is a more efficient way to get to the point. That's what an equation allows us, one of the things that an equation allows us to do. So if I wanted to jump to, say, 10 seconds, well, I would substitute 10 here, because that's how many of those 4.44 steps I would take. And you can see the calculation here, 4.44 times 10, that's 44.4. Don't forget to add our starting value. And so we've got 44.4 meters. Clean that up there. 44.4 meters at 10 seconds. Well, let's say I want to jump to 45 seconds. Let's see if that really matches up with what we know. I mean, we know that Eli should be finished, the 200 meters here. Well, if we put 45 seconds and we multiply it by that 4.44, indeed, what we end up getting, if we round to the nearest meter there, what we end up getting is exactly what we expect. And so what we've confirmed is that our equation really works. Now we could go ahead and generate any of those times that we want. And so I've just thrown that into this slide here to show you that any of these times can be calculated. We can zoom in and think about where he'll be at any particular point in time in this essentially 45 second race time. And notice I can continue to think about that pattern if I want, but we know that our race will end here. This is our finish line. Now I've continued to do that because, what if we wanted to think about a longer race? Now, what's awesome about this whole exploration that we've done is that we can jump right to that equation when we think about Georgie's race. And we can certainly break it down slowly and do the table, and I would invite you to do that. But again, the process is really the same. First, we think about his rate, and I really want that in meters per second. So I took his 200 meters in 60 seconds. Georgie's a little bit slower. And we calculated that would be 3.33 meters per second. And that's just dividing that 200 divided by 60. And again, because we understand the linear pattern of this, our equation will just be y equals 3.33 x plus 0. If we wanted to, we could just write this. We could get rid of the 0 because adding 0 really doesn't change our value. I mean, if you ask me, hey, how old are you, Mr. Morin? I wouldn't tell you, hey, well, I'm 47 plus 0. We would just say, well, that's just 47. Okay. And so again, we can use this to generate any of the points that we really want to know about. So let's say we wanted to know, hey, where is Georgie going to be on the track at 10 seconds? So again, we would just substitute that 10 into where the time is, 3.33 times 10, and we could say, oh, well, at 10 seconds from the start of the race, or 10 seconds into the race, he would be at 33.3 meters. We can compare that if we want back to Eli in the first 10 seconds. So he'd be about 10 meters ahead. He'd be at 44 meters, whereas Georgie would only be at 33.3, so about 11 meters ahead. Now again, we could go ahead and generate all of those other values for the rest of Georgie's race by just calculating each of those values in our table. Now, what's interesting here is, again, this matches up with what we thought about George. He's going to do the 200 meters in 60 seconds, and so you can see that point here at the end of our table. But also, if I'm interested in knowing, hey, when Eli finishes, because Eli's race was only going to take 45 seconds, how far back will Georgie be? Well, this is where Georgie will be in 45 seconds into the race. He'll only be at 150 meters. So Eli can look back as he finishes the race and look back, and he'll see Georgie will be 50 meters back. And so this allows us to really finely look at the whole story and really zoom in on any particular point that we want in the story of this race by using this equation. So we're going to practice this week. You have a Khan Academy assignment that's going to help you to practice going from stories to writing equations. Please make sure that you do that practice, and I will see you next week.